1, 2, 3.
Hi.
We're Group 37. I'm Zona. I major in international business, and I'm going to answer question number 1.
And I'm Eric. I'm majoring in risk management and insurance, and I'm going to answer question number 2.
I'm Rachel, and I'm major in international business, and I'm going to answer question number 3.
I'm Sabrina, and I major in international business, and I'm going to answer question number 4.
I'm Surrey, majoring in international business, and I'm going to answer question number 5. So let's move on to a slide. Question 1. Quanta operates a fleet of over 100 Boeing jet aircraft. Commercial passengers jets must be operated by a pilot and co-pilot. Consider each of the following costs. Identify which are fixed costs of passenger services and which are variable costs of passenger services. First, let me clarify the idea of fixed cost and variable cost. The definition of fixed cost is costs that do not vary with the quantity of output produced, which even incurred even if the firm produces nothing at all. In contrast, variable costs are costs that vary with the quantity of output produced. For example, commission, direct labor costs, and utility costs. So let us go back to the question. A. Cockpit personnel. All jets, large and small, require a pilot and co-pilot. Belly cargo service requires no additional workers in the cockpit. We consider this one as fixed cost because the staff assignments, including pilots and co-pilots, are the same in different types of jets. B. Airport landing fees. Some airports charge landing fees by weight of the aircraft, while others levy a fixed fee, regardless of weight. This one is variable cost for Qantas because landing fees vary in different places. C. Fuel. Larger aircraft and those carrying heavier loads will consume relatively more fuel. It's obviously variable cost because the cost of fuel alters when the weight of jets changes. I'm done with my slide.
Question 2. Barrick Gold owns the Bulyanhulu mine in Tanzania and the Kalgoorlie mine in Australia. Table 1 reports information on selling price and cost for the two mines. Barrick's selling price of gold differs from the spot price as some production is sold through long-term contract and also owing to the company's use of hedging. The average cash cost, average variable cost, includes operating costs, royalties, and taxes, while the average cost includes the cash cost as well as amortization. A. Suppose that the Bulyanhulu mine always produces at a scale where its marginal cost equals the selling price of gold. Its marginal cost curve, however, shifts with changes in electricity prices, wages, and other factors. Using the data from Table 1, illustrate the shifts in Bulyanhulu marginal cost curve, the selling price, and profit maximizing scale of production between 2002 and 2004. As the graph below shows, the marginal cost curve shows the 2002, 2003, 2004 marginal cost curve, and the profit maximizing scale of 2002 will produce 356 and price will be 391, and in 2004 have to produce 315 and price will be 391, and in 2003 have to produce 314 and price is 366. B. In 2003, Barrick continued to produce from the Bulyanhulu mine even though the selling price of gold, 366 per ounce, was less than its average production cost of 369 per ounce. Was this a mistake? No. We consider that the average variable cost would be 246 if the variable cost is the cash cost. Thus, the price will exceed the average variable cost. Also, provided that Barrick stop producing, they have to meet the condition that price is lower than average variable cost. Hence, it is reasonable for Barrick continue to produce. C. Use Barrick's 2004 data to compare the short-run break-even conditions for Bulyanhulu and Kalgoorlie, and the long-run break-even conditions for the two. And here is table 1. And before giving our answer, I want to clarify some conception. In the short run, the total cost includes variable costs and fixed costs. However, in the long run, the total cost is equal to variable cost, and the condition of finding break-even point is that the total revenue equal to total cost, which will earn zero economic profit. Thus, in the short run, the break-even condition of Company B will be 384. And Company K will be 278. In the long run, ignoring the amortization fee, the break-even point will be 284 and the Company K will be 234. And I'm done with my question.
Question number 3. A firm faces the current conditions shown in Table 2. In Table 2, the price is 100, the quantity is 1,000, the total cost is 100,000, the variable cost is 90,000, and the fixed cost is 10,000. A. Suppose this firm is a perfectly competitive firm. Its average variable cost is minimized at the current quantity level. Do you think if this competitive firm is maximizing its profit? Explain why. As a consultant of this firm, what are you going to suggest the firm to do on its production level in the short run? Explain why. Graphical and descriptive analysis are required. The answer is that the firm is not maximizing its profit. The average total cost is 100 and the average variable cost is 90, which means that the firm should increase production. B. Suppose this firm is a monopoly firm. Its average total cost is minimized at the current quantity level. Do you think if this monopoly firm is maximizing its profit? Explain why. As a consultant of this firm, what are you going to suggest the firm to do on its production level and price level in the short run? Explain why. Graphical and descriptive analysis are required. The answer is the average total cost is 100, which equals marginal cost and price, and monopoly price equals 100, which is larger than marginal revenue. Because marginal revenue doesn't equal marginal cost, the firm's profit is not maximized. The firm should decrease production.
Question 4. Referring to the following Figure 1, suppose that Mercury Airlines' marginal revenue and demand curves cross the marginal cost curve at quantities of 3,000 and 6,000 seats a week, respectively. All other data remain the same. A. Calculate the profit under policies of first, uniform pricing, single profit maximizing price at profit maximizing quantity, and second, complete price discrimination.
This first one, uniform pricing. Under this system, the profit maximizing quantity is where marginal revenue equals marginal cost. Referring to the figure, at that point, the quantity is equals to 3,000. And at that quantity, the price on the demand curve must be halfway between 800 and 4,000. And now we can calculate out the price by similar triangle. The price is equal to 2,400. And also we can calculate out the profit, which is this rectangle, and the profit is equals to 4.8 million dirhams a week. For the second one, complete price discrimination. Under this system, the seller should sell the quantity where marginal benefit equals marginal cost, which is at the quantity equals 6,000 at this point. And then we can calculate out the total revenue, which is the area under the demand curve up to quantity equals 6,000. And we can know that the total revenue is 14.4 million. And then the total cost is this area, which is equals to 4.8 million. And by total revenue and total cost, we can calculate out the profit, which is equals to 9.6 million. B. Suppose that Mercury implements complete price discrimination. Explain why it should sell up to the quantity where the buyer's marginal benefit equals Mercury's marginal cost. Mercury maximizes its profit by producing the quantity where the buyer's marginal benefit equals Mercury's marginal cost. If it sold a larger quantity, so that the marginal benefit is less than the marginal cost, then its profit would be lower. By contrast, if it sold a smaller quantity, it could increase price by selling one more. C. Explain why Mercury's profit is higher with complete price discrimination than with uniform pricing. Complete price discrimination yields more profit than uniform pricing because it extracts a higher price from existing buyers and extends sales to new buyers who would not be served under uniform pricing. So, that's all for my question.
Question 5. The demand for most new films is the highest in the first few days after opening, then tapers off. Two key factors affecting potential demands are the season and the timing of other releases. Suppose that both Studio Luna and Moonlight Movies are producing major action movies. The two studios simultaneously must choose between release on December 11th and 18th. If both films opens on December 11th, each will sell 200,000 tickets. If one opens on December 11th and the other on December 18th, then the early release will sell 350,000 tickets, while the later release will sell 150,000. If both open on December 18th, each will sell 100,000 tickets. In a strategic form. There are two players in the game, Studio Luna and Moonlight Movies. And there are two strategies, release new films on December 11th or on December 18th. In this case, we use arrow strategy to find a Nash equilibrium. Given that Studio Luna choose to release on 12/11th, Moonlight Movies gains 200,000 if releasing on December 11th, and 150,000 if releasing on 12/18th. 200,000 is better than 150,000, so let's using arrow to point 150,000 to 250,000. Given the studio Luna choose to release on December 18th, Moonlight Movies gains 350,000 if releasing on December 11th, and 100,000 if releasing on December 18th. So we use arrow to point 100,000 to 350,000. Now we see this section with the two arrows pointing together, so the Nash equilibrium is that both films choose to release new films on December 11th. They choose their best strategy available given the strategy the other is following. B. Now suppose that the publicity surrounding one movie will increase the demand for the other film. Specifically, each studio will sell 7,000 more tickets if both open on the same day. Adjust the data in A according to this new information. How does this affect the equilibrium? Given that Studio Luna chose to release on December 11th, Moonlight Movies gained 270,000 if releasing on December 11th, and 150,000 if releasing on December 18th. 270,000 is better than 150,000, so let's using arrow to point 150,000 to 270,000. Given that Studio Luna choose to release on December 18th, Moonlight Movies gain 350,000 if releasing on December 11th, and 150,000 if releasing on December 18th. So we use arrow to point 170,000 to 350,000. Now we see this section with the two arrows pointing together, so the Nash equilibrium is still the same according to the data from QB. I'm done with my questions. You're listening.